Imagine you spend months building up to a massive product launch.
Right.
The confetti barely hits the floor. The tech world is cheering loudly.
Yeah, everyone is celebrating.
And then your biggest rival drops a next-generation model. They drop it right on top of your news cycle.
Oh, it is brutal.
That is exactly what OpenAI just did to Anthropic. Fable 5 had barely launched.
Fury out the door.
Right. And then GPT-5.6 Sol under the chat. It feels like a sudden clash of AI titans.
It really does.
Which one actually takes the crown right now? Welcome to the deep dive. Today we are exploring a real head-to-head performance comparison. We are looking closely at GPT-5.6 Sol and Fable 5. We will rely strictly on the hard benchmark data.
Just the data.
We are also looking at OpenX coding demos. And we will review direct ChatGPT chat interface tests.
Yeah, we are not taking sides here.
Not at all. We just want to unpack the data for you. We want to help you figure out the best tool. It is all about fitting your specific daily workflow. Okay, let's unpack this.
Yeah, the timing from OpenAI was definitely not an accident. Fable 5 was getting a ton of immediate attention everywhere.
Right.
OpenAI clearly wanted to shift that spotlight back. They wanted it back on their own ecosystem, beat. But marketing timing does not automatically equal better performance.
No, it definitely doesn't.
We have to look past the shiny launch announcements. We need to see how these models actually handle work. We need to understand the real underlying mechanics.
Exactly. We need to see what OpenAI actually built first. Let us look at the new GPT 5.6 model family.
Yeah.
It is actually broken down into 3 distinct models. You have Sol, which is the massive flagship model.
Right.
Sol is built for complex, multi-step professional work tasks. It handles heavy coding and deep research workflows.
Then you have Terra sitting right in the middle. Terra gives you a highly balanced mix of performance and cost. It is designed for everyday tasks needing reliable logic. Finally, there is Luna for the lighter, rapid workloads.
Right, the fast one.
Exactly. Luna is basically built for blazing fast data crunching. It handles large-scale text processing at a much lower cost.
Inside ChatGPT itself, Sol has different reasoning levels available. You can choose medium high or extra high reasoning.
Which is pretty cool.
It depends entirely on how difficult your specific task is. There is also a Sol Pro version available now. Sol Pro gives the model extra compute to check its work.
Right, and when a task requires multiple complex steps, checking work is critical.
Yeah.
It allows the model to spot its own logical errors.
Honestly, I still wrestle with prompt drift myself.
Absolutely.
You know, when the AI slowly forgets your instructions over a long chat. So navigating this many model modes just feels daunting.
Yeah, I totally get that.
I have to play devil's advocate here. As a user, staring at a massive drop-down menu feels overwhelming. You have medium high, extra high, Pro, Max, and Ultra.
It is a lot.
Is this multi-mode setup unnecessarily complicated for the average user? Are they overcomplicating this just to monetize different compute tiers?
Well, it definitely looks like choice paralysis at first glance. But it is really about maximizing your overall efficiency.
Okay.
You match the specific tool to the size of the task. Using Sol Pro for a simple summary is just wasteful.
Right.
It burns expensive compute power and wastes your valuable time. By picking the right tier, you save money and energy.
Makes sense.
Also, they included a max mode for deep reasoning. Max mode just gives Sol much more time to think. It allows the model to map out complex logic trees. And then there is the highly anticipated Ultra mode.
Right. Ultra mode uses parallel subagents for massive tasks.
Right. And subagents are just tiny digital workers splitting up a task. Think of it like a bustling restaurant kitchen. Instead of one master chef cooking a 5-course meal sequentially,
Right.
you have a head chef instantly delegating to a dozen sous chefs. They chop, boil, and bake simultaneously.
That's a great analogy.
It is highly efficient for massive workflows and data analysis. They can process information much faster than a single worker.
We should also mention the specific API costs involved. Through the API, Sol costs $5 per million input tokens.
Yeah.
And it costs $30 per million output tokens. That can add up incredibly fast if you run heavy automation.
Exactly. That is why the different compute tiers are actually helpful. They let developers control their exact server spending.
Right, so don't use a sledgehammer to crack a tiny nut.
Precisely. Do not pay for a supercomputer to write an email.
Okay, so Sol has this brute force parallel processing power. But massive compute power does not always equal true intelligence.
No, it doesn't.
How does Sol actually perform against Fable 5 in blind testing? Does that extra compute translate to higher benchmark scores?
What's fascinating here is where Sol clearly pulls ahead. Sol dominates in long professional tasks and direct execution.
Okay.
Take the agent's last exam benchmark, for example. This test measures if an AI can stay entirely focused. It tests long workflows without getting distracted or confused. Sol scored 52.7% on this exam. Fable 5 only reached 40.5%. That is a pretty significant gap in overall performance.
Sol also leads in the important coding agent tests. On the Artificial Analysis Coding Agent Index, Sol scored 80.
Yeah.
Fable 5 was close, but trailed slightly at 77.2. But here's the really interesting mechanical detail. Sol actually used far fewer output tokens to finish the job.
That matters because it looks beyond just the final code. It means Sol is not just babbling to find an answer.
Right.
It writes concise, efficient code without wasting your money. We see a similar result on DeepSWE version 1.1. Sol scored 72.7% against Fable 5 at 69.7. Sol excels at handling long, sequential software engineering tasks.
What about command line work and terminal testing benchmarks? This is where the AI types raw code into a black box.
Right. No safety net.
There is no pretty user interface to guide it. Sol performed incredibly well on Terminal Bench 2.1. Sol scored 88.8% against Fable 5 at 83.1%.
Wow.
And when they turned on Sol Ultra Mode, it hit an impressive 91.9% on that raw test.
That Ultra Mode score proves the real value of subagents. Breaking a large, complex task into smaller parts really works.
Yeah.
It helps the model coordinate different tools and plan automatic retries.
Sol also has a clear advantage in deep web research. BrowseComp tests complex searches across multiple different web sources.
Right.
It requires the model to connect information from several isolated places. Sol scored 90.4% on this specific test.
That is high.
And Sol Ultra reached an amazing 92.2%. According to the chart, Fable 5 only managed 84.3%.
Interestingly, 16 agent setups reach high scores much faster. Single agents need way more time to get anywhere close. This proves that parallel processing is the future of deep research.
Thank you.
But we have to look at the other side of the coin.
Right. Fable 5 still wins some very important standardized benchmarks. On the Artificial Analysis Intelligence Index, Fable 5 scored 59.9.
Yeah.
Sol is just slightly behind at exactly 58.9. So Fable 5 still edges out in general, broad intelligence.
And the gap becomes absolutely huge on SW Bench Pro. Fable 5 scored an incredible 80% on this test.
Wow.
Sol hit a much lower 64.6%. SW Bench uses real-world repository issues for its tests.
Right.
Imagine dropping an AI into a 10,000-line existing code base. It has never seen this specific code before. You give it a vague bug report and tell it to fix it.
That sounds like an absolute nightmare for any developer.
It is. But Fable 5 dominates when dealing with these massive code bases.
Why does Sol crush coding agents but lose so badly to Fable 5 on SW Bench repository coding?
Well, it comes down to their underlying architectural differences. Sol is optimized for step-by-step logic gates.
Okay.
It excels at sequential tool use and direct execution. It is great at taking the next immediate logical step.
Right.
But sometimes it forgets what room of the house it is building. Fable 5 handles broad reasoning much better. Its training heavily emphasized wider context window retrieval.
And a context window is just the AI's short-term memory for reading files.
Right. Fable 5 can hold the blueprint of an app in memory. It understands how a small change affects an entire existing code base. It sees the big picture much better than Sol does.
So Sol is the marathon runner, while Fable is the architect.
That is the perfect way to look at it. Sol will flawlessly run the miles, but Fable draws the map.
Benchmarks are sterile and highly controlled testing environments. What happens when real developers throw messy tasks at them?
Yeah.
We looked at some open-ended community tasks shared on X. These coding demos show us the models in real action.
This is where we see how they actually behave under pressure. One user had Sol build a complete Replit-style coding app.
Wow.
It was entirely generated from just one single text prompt.
That is mind-blowing. The project included a database and isolated code sandboxes. It even had an app-building agent inside the main app.
Yeah.
That is basically an AI creating another AI to build things. Sol had to connect all these moving product parts together.
Exactly.
It had to keep the same goal across a long build.
That is far more complex than a simple landing page. It requires maintaining context over a very long generation period.
Another amazing test involved building a complex spaceship game. Sol worked continuously on the spaceship game for 87 minutes.
Yeah.
The previous model GPT 5.5 stopped working after just 35 minutes.
Whoa. Imagine an AI staying actively focused on coding a single spaceship for 87 minutes straight without losing the plot. 2-sec silence.
It is wild.
Usually an AI's context window degrades over time. It starts hallucinating or writing bad code loops.
Right.
But Sol kept fixing its own physics engine bugs continuously. That level of sheer persistence is a huge leap forward.
Yeah.
It matters heavily when coding requires constant, tedious checks.
There was also a head-to-head Minecraft clone test. This was a massive undertaking for both AI models. Sol finished building the clone in 70 minutes via Devon. Fable 5 took 90 minutes using Claude code. Now, they ran in completely different development environments.
Different setups.
So it is not a perfectly clean speed test comparison, but it still shows incredible stamina for both of these models.
Definitely.
But I have to ask about the actual output quality.
Yeah.
Does a longer runtime, like that 87-minute session, actually guarantee better code?
No, persistence is great for fixing immediate surface-level errors. But runtime alone does not prove the final code is clean.
Right.
It does not mean the architecture is structurally reliable. It just means the AI keeps blindly trying to solve the problem.
Okay.
A bad architectural foundation will not improve just by running longer.
Longer focus is great, but quality still needs a human check.
Always. You can never fully remove the human element. The developer still has to verify the final code structure. Mid-roll, sponsor, read, placeholder.
Those are massive developer tasks we just talked about. But how does Sol handle granular everyday chat requests?
Yeah.
What happens when you throw a daily research task at it?
They tested Sol on researching conflicting evidence from different sources. This is a very common task for managers and developers today.
Very common.
They asked the AI a very specific, highly debated question. They asked if AI coding assistants actually speed up delivery. And they asked if they cause more production bugs over time.
A simple web summary is definitely not enough for that. Sol had to check original evidence and explain the key differences.
Right.
It successfully prioritized original academic studies over marketing fluff. It cited specific numerical claims from the actual GitHub commit data. It completely separated company blog posts from measured scientific findings.
It also explicitly stated what the evidence cannot actually prove. That kind of nuance is incredibly valuable for deep research.
Yes, it is.
It does not just blindly agree with the user's initial prompt. It actively looks for public datasets and engineering reports to verify claims.
Here's where it gets really interesting. Sol is also genuinely great at deep file analysis.
Yeah.
You can upload complex spreadsheets or dense PDF reports. It finds data errors without guessing any missing values.
Right.
It completely refuses to confuse basic correlation with actual causation.
It stays incredibly close to the facts presented in the file. It does not fill in the blanks with reasonable-sounding assumptions.
That is huge.
That makes it a much safer tool for sensitive data analysis. It clearly labels anything that is only a statistical possibility.
They also tested Sol on rebuilding a basic visual chart. The original chart did not have any exact value labels.
Right.
Sol rebuilt it into a clean, professional presentation slide. It added branding, footers, and a nice professional page number.
It even moved the market labels so they did not cover data. The new version is much easier to read and compare.
Wow.
But there is a very crucial mechanical caveat here to remember. The original image lacked exact numerical values for the bars.
Okay.
So Sol most likely visually estimated the bar heights. It was literally guessing numbers based on pixels and proportions.
Wait. If it's just estimating chart values based on bar heights, can we trust the final slide it generates?
Absolutely not for final reporting to your boss. You must manually verify every single number before putting it in a presentation. It is just estimating values based on visual pixels. It is not actually calculating the underlying financial data.
It makes things pretty, but you still have to verify the math.
Right. It is a design assistant, not your certified accountant. You still own the final numbers on that slide.
So what does this all mean for you? We have pulled together all these benchmarks and wild X demos.
Yep.
We have looked at the daily chat interface tests too. We need to answer the ultimate question for you today. Which model should you actually choose for your daily workflow?
Well, if we connect this to the bigger picture, you should absolutely choose GPT 5.6 Sol for a few specific things.
Okay.
Use it for deep web research involving multiple conflicting sources. Use it for tasks requiring heavy tool use and terminal commands. It is phenomenal for long tasks with incredibly clear success criteria. And use it when you can check the work step by step.
Sol's clearly built for rigorous step-by-step execution. It follows the precise path you set out for it perfectly. But you should choose Fable 5 for different reasons entirely. Use Fable 5 for open-ended planning and massive repository-level coding.
Right.
It is better for tasks where deep judgment matters more than speed.
Fable 5 has a much stronger sense of broader direction. It holds that structural blueprint in its context window.
Yeah.
It understands what should logically happen next in a complex system. It is the much safer option for code-based work needing real judgment.
Sol executes the specific steps. Fable 5 decides the overall direction. I want to leave you with a final thought today. Sol is becoming an absolutely unstoppable doer for software developers.
Yeah.
It can work for 87 minutes straight without ever quitting.
Yeah, it's wild.
Meanwhile, Fable 5 is becoming a master planner for system architecture. It can handle vast, complex code bases with deep, human-like judgment. Beat. What happens when developers figure out how to seamlessly chain these two models together?
Oh, man.
Imagine Fable 5's architectural planning guiding Sol's relentless 87-minute execution.
Yeah, that is when things will get truly wild. We might see completely autonomous software engineering teams very soon.
Thank you for taking this deep dive with us today. We hope this helps you choose the right tool for your workflow. We will see you next time. Out to your own music.